Open source Git native CDN PaaS (TAO) is a framework for building low-maintenance and highly scalable cloud computing platforms that software developers will love. TAO is a single binary with no external dependencies except standard system libraries. On top of that, it requires minimal configuration. These are the main steps. Install TAO curl http://get.link/tau configure TAO config generate n your domain.com services all nash IP your IP launch. For a complete step-by-step guide, refer to Deploy TAO. Building TAO yourself is a straightforward Go build given you have Go installed. Background: the cost and time required to build software, take it from the development environment to production, and then scale it effectively to meet end-user demand are extremely high. Developer-friendly platforms, like the major cloud computing providers, are expensive, lock users in, and overlook local development and E2E testing. This is really a two-sided problem. Do you save on infrastructure cost or do you lower development time? If you invest in your platform, it's a rocky road that impedes the speed of development and generally ends up costing more. We all know the Kubernetes fairy tale does not end well. If you invest in development speed, you're limited by your provider's features and cost. To us, solving this problem means giving you or your very small team the ability to build and maintain a cloud computing platform that will go head-to-head with the ones backed by thousands of engineers, setting software developers free from infrastructure and operational constraints. We refer to this as local coding equals global production. TAO solves for building and maintaining a cloud computing platform and also provides the foundations for an amazing developer experience. Minimal configuration. One of the reasons TAO requires minimal configuration is because it has built-in auto-discovery. Just like a self-driving car gathering information through sensors, TAO will gather information and try to find the best ways to be reachable, available, etc. That said, some configuration like bootstrap peers is necessary. Unless you're running a single-node cloud, each node will need to know at least one other peer. A cloud built with TAO is very dynamic. At a low level, nodes communicate assets, routes, and services, and they also exchange information about other peers. Enriched by distributed services like Seer and Gateway, the cloud can load balance incoming requests to ensure optimal performance and reliability. This behavior is built into cloud resources as well. For example, a protocol we call Hoarder ensures object storages and databases are replicated. All you need to do is enable it on a few nodes. Local coding equals global production. In your traditional setup, the platform is a complex set of templates, pipelines, and integrations that ultimately help turn configuration into API calls and code into assets. Because of that complexity, and also the fact that many components need to run inside a very complex environment of their own, it's impossible to satisfy the local production equation. Granted, there are some solutions that either mock or reroute to dev prod resources, enabling developers to build or debug locally. However, it's still a third-party service you need to integrate and manage. In order to satisfy the equation, we decided to build TAO so it simplifies ports and/or sandboxes every aspect of the cloud. Git native. Traditionally, you interface with infrastructure through API calls. This is the case for every cloud computing provider alongside orchestration solutions like Kubernetes. A few years back, the concept of GitOps started to make waves, and that was around the time we started building, so we decided to cut the unnecessary garbage between the definition of a cloud resource, which should be stored in Git, and its instantiation. As a result, TAO has no API calls to create a serverless function. For Exa,